with a crutch, so that's nice. I also brought some props. I was told no PowerPoint, so I expect some 8.5 by 11, but it seems a little bit ineffectual for this many people. But I think
Sam, use the microphone.
Yes.
is that better?
Yes.
I have some handouts that is not nearly enough, but I'll send maybe these, in this direction. And then this is a 3D printed surface, which I will explain. And I'll pass that in that person, and the person will get to see them both at the same time. So thank you, Hugh, for inviting me. I'm a Dow architecture student, and I'm working on my thesis right now, and it's been kind of a long and varied project, but I'm just going to kind of run through my research, I guess, is my plan for today. I wasn't 100% sure how to structure this, but I started out really thinking about kind of a modular architecture system where there was a plinth and then some kind of a modular wooden structure, basically, that would be changeable over time. And this was my running idea probably 2 years ago when I really first started thinking about the thesis project. And what I was interested in was the kind of time-scale differences, the idea of kind of a permanent plinth and then this mutable, modular superstructure. And what I ended up ditching was the concrete. I realized that maybe concrete wasn't nearly as permanent as I initially thought, and it kind of really just bothered me from a personal perspective. I was like, if the idea of this thing is that the wood structure can be modular for generations, the concrete needs to last more than 100 years or whatever. It needs to be kind of more permanent. And in doing research on kind of modular timber structures, I was looking at Japanese architecture and Japanese timber framing, and there's a particular joint where they basically array natural stones and then scribe a piece of wood to the stone perfectly. It's a really long and laborious process. Generally, they're pretty big pieces of wood, and the process is to build a big tripod and then lift the piece up and have some kind of marking material on the rock and slowly carve away until you have kind of as near a surface match as you can between the wood and the rock. And a couple of reasons that they did this, it was, especially when it was popular, it was earthquake resistant as far as contemporary building techniques were. It allowed the piece of wood to move a little bit on the rock, but not break, basically, because it had this loose connection where there was no pin or anything. It's also nice because often this would be joined to the superstructure, so this was kind of a sacrificial piece. It's nice that this contained a lot of the information and the hard work of scribing, but in the end, that piece would be remade over and over. So there are buildings in Japan that have existed using this technique for 1,500 years that are still standing and still using this technique. So I guess there's a sustainability problem that I was trying to solve at this juncture, but I kind of have branched from that, and I became enamored with this joint and started researching if you could digitally manufacture that. So how do you get that 3D model of the rock or vice versa, and how do you kind of translate that into the digital design realm where so much design happens these days, and then how do you bring that information back out of the computer and into the physical world. And so the way to do that basically is using LiDAR or photogrammetry are the two scanning techniques that I've used. So photogrammetry, if you have a rock, basically you build kind of a halo around it, and then take a picture of the rock from until you have an accurate 360-degree view of the rock. And then you bring that into the computer, it creates a point cloud based on these images, and then you can convert that point cloud into a mesh, which I can talk about a little bit more later, I guess, but this is basically the most high-res scans that I can get is with photogrammetry. LiDAR is an active scanner, so it sends out a laser and records how far that laser has to go before it bounces back and hits the LiDAR scanner. And it's good if the subject is static, but it's really, especially for, I'm using my phone with the LiDAR scanner, and it's not nearly as accurate. What I'm interested in now really is kind of finishing my thesis, and what that has turned into is really like, what are the applications for this? So what are the applications at different scales? One of the images there is a tape dispenser that's kind of a very design heavy. I don't know, they're selling them for $500 a piece, $500 to $800 a piece, and it's just a rock with a little 3D printed attachment that is glued to the rock, and it will dispense your tape. This is the first time that I've ever seen this kind of technology used in a design platform, really. There's lots of people who have scanned natural items and then manufactured connections like on them, but the connecting piece is always computer drafted geometry to another computer drafted geometry. And so what's interesting about the tape dispenser and this is that you are attempting to graft onto a natural surface, which is complicated. It's interesting for architecture because most architects that I've talked to really don't like the idea that there's no connection, there's no pin or anything. So it's a little bit contentious, I would say. But from a design standpoint, I find it really interesting. I'm glad Emmanuel kind of teed me up because I don't really feel like I am addressing a problem, but I'm really exploring this methodology of scanning, digitizing, and then bringing it back into the physical world. And so the digital manufacturing side is where the problem solving really happens, because at Dow we don't have necessarily all of the options for digital manufacturing. I'm probably over time right now, but what I have been doing is basically approaching different methods of reproducing a surface. So there's milling, there's 3D printing, and what I'm working on right now is kind of a flat cut solution. So some of the renders are using that to create kind of a chair that is a bespoke piece that would only sit kind of on an individual rock. It's a little bit cerebral, I guess, not really, but it's a little bit, I don't know what the word is, useless. It's like
Unessential.
Unessential, yeah. It's a experiment. This whole thing is definitely an experiment in where this technology could go, basically. So I'm happy to answer any other questions. I know that my 5 minutes now. But there's also a rock surface going around, so you can see the kind of contours. And that is actually a LiDAR scan. It's not a photogrammetry scan, so that is kind of the mid-tier of kind of the resolution that you can get. I'm working on a site in Nova Scotia to kind of design an architectural intervention using this scanning procedure, and that's probably my time.
Hi. Sorry.
I mean, from our conversations, I know that you're thinking about Nova Scotia in that context. Can you talk a little bit about where you see this being applied?
Yeah. So I do think that I've selected a site, Polly's Cove, very close to Peggy's Cove. It's basically just a site that I selected because of the rocks that are there. So there's lots of different places in Nova Scotia that you could, I think, apply this kind of idea, but that site is beautiful because it has these big granite bedrock faces that are exposed from the wind, and then it has some really beautiful granite erratics that are scattered on top of that. So I think I selected the site because it's close to Halifax and I can get there pretty regularly, but also I think it's interesting to leverage both the kind of larger ground surface and then also these kind of freestanding but very heavy objects that you could apply the same technology to as options for design, I guess. Yeah.
I'm very curious to know your definition of art. Everything, including everything but Emma said to me, I'm a designer by the way, sounds very artistic. So I'm very curious to know, like, from your perspective, what is art?
That's maybe a long answer. I mean, actually maybe not. I think I would define art probably as, self-expression. I think that is maybe the most encompassing, and through some kind of medium. So I do think that there is this kind of, I don't know about like what I'm self-expressing here really, but I do think that there is this moment between like the rock and the attempt to recreate the natural surface that I find very beautiful. I think it's very beautiful when you do it by hand, but I think that part of this project is really exploring, if that, what I see there, that kind of attempting to recreate a natural object is, if that value that I see in the hand work is also in the digital manufacturing. And so far, I do think that it is. Like, it's been very rewarding every time you get a surface to closely fit another surface, and that's really been the exploration. There's some joy that happens there when you get the fit just right. And I really meant to talk a lot more about the methodology, kind of dealing with 3D modeling programs and the information that you get from the scans, because they don't always play that nicely together. And especially with the manufacturing side of things, that's where a lot of the problem, like designing, has taken place. Is how do you recreate the surface, but maybe not in a solid block. But so right now I'm working on a lattice structure, the chair in parentheses. But basically, if you drew like a grid on top of this, and then pulled those lines down to the rock surface, so that you have kind of this grid structure over the rock, that allows you to do different things in manufacturing, because if you're flat cutting with a CNC, it really wants a two-dimensional line. You can't use, so the mesh becomes less useful. You really need to get these kind of planar objects. So there's a lot of troubleshooting, I guess, between like figuring out how you're going to manufacture it, how you're going to design on top of that, and really it's like I haven't gotten too deep into the design portion because I have been kind of dealing with these manufacturing and kind of representational issues.
What excites me the most is that it's not just artistic, it's also very ceremonial and ritual. There's a ceremonial quality to how you made this place or this situation very special. It's not special for your project. There's a number of possibilities that you're able to resolve or solve out of this. Whether it be having to different materials that you can work with. I just wanted to mention that in Japan, there's this very sacred place called the Ise Shrine. And they build, it's a very ancient shrine, attributed to this, some god or some, and they rebuild this place every 25 years, I think, since the 14th century or something. I don't know if you've ever seen that. So there's the possibility that exists and work is really exciting. Thank you.
Yeah, thank you. Yeah, in the process of this research, I went to Japan and went to Ise and Itsushima near Hiroshima. I was really looking for this kind of technique everywhere, and I did find it kind of in, I would say, like almost trim features a lot. Like, we scribe things here, but rarely in a structural capacity. It's almost always like a fascia we'll scribe in carpentry, but I think that it's such a profound thing to have the building kind of resting without a fixed connection, and it works like for over 1,000 years. So it's really interesting to me, like how that can be, integrated into and almost saved. I think because it's really mostly used now for kind of UNESCO heritage sites and kind of not as vernacular of a technique.
Good. I think it's getting late. I also find it again very interesting, and we could probably continue talking about it. But as I said, let's get to the next speaker, and then once we finish, please just mingle and continue asking questions. Okay? Thank you so much. Our last speaker is